Parts per million, take 3. This is one of my grannies. Had them for a while. You ever wonder how fish breathe? A lot of people have misconceptions. They think fish, oh, they breathe the oxygen in water, and they think that they're doing chemical decomposition of H2O. That's definitely not the case. Water will dissolve to a small degree oxygen. I mean a small degree. Here's water. It's a polar molecule. You don't foul mouth Mickey. And the green ones here, those are oxygen molecules. You won't get many non-polar molecules to dissolve in other polar molecules, but it'll be more than 0. Typical fish tank has a dissolved oxygen concentration somewhere around 12 parts per million. So 12 unit of mass oxygens per million unit of mass solutions. Now, in our percent composition questions, we said, well, it was part over whole times 100, and we had to add the parts together to get the whole. But when the concentration is very, very low, the parts per million, they're already in the solution. It's 12 out of these million. These 12 are already in there. You don't need to add them together. So that's perhaps the biggest thing you should talk about here. You don't need to add part plus other part. It's already in there. So if I said how many grams of oxygen are in 1 liter of aquarium water? Well, the aquarium water, that's your solution. That's the whole. You're looking for grams of oxygen. But they started you off with liters of water, which is kind of goofy, but I did that intentionally because the worksheets seem to really want to hammer home that the density of water is 1 gram per mil. So if it's 1 gram per mil, it's 1 kilogram per liter. So 1 liter of aquarium water is 1 kilogram of aquarium water. So now we've got grams of oxygen and kilograms of solution. It's apples to apples. Whatever your parts per million are expressed in, that unit of mass here has to be the same as unit of mass here, and then you go times a million, which is 10 to the 6th power. So you need to convert one or the other to get that ratio. So if I've got 1 liter of water, I've got a kilogram of water, and they want to know how many grams, you can convert at the end or you can convert in the beginning. It doesn't really matter. I guess I'm going to convert at the beginning. So my parts per million, that's 12. You can do this a bunch of different ways. I said aquarium water is 12 ppm dissolved oxygen. So if I divide each side of this equation by a million, I could say ppm over a million is equal to part over whole. Just get these units to match, apples to apples. So it's 12 out of a million. And if I want to work in grams, well, there are 1,000 grams of solution. That's the whole. So I'll put 1,000 down here and put X up here. Okay, this is the algebraic solution. We'll do it dimensionally next. Cross multiply. A million X is 12 times 1,000. Divide by a million. I believe that's 0.012. I don't trust my math. My brain is not functioning on all cylinders this morning for whatever reason. If I plug that in correctly, that's 0.012 grams of oxygen in there. So let's try that dimensionally. you've got 1 liter of solution. Density is 1. It's a very low concentration of oxygen, so it's not changing the density of water. So we'll just label these both solution. A kilogram of solution is 1,000 grams of solution. And finally, there are 12 grams of oxygen per million grams of solution. So basically, 1,000 times 12 divided by 1,000,000, and you get the same answer. Recurring theme in this unit, I don't care if you do it dimensionally or algebraically. I think people's brains are wired a little bit differently. But that's all right. How you do it is how you do it. Let's go over an example from the worksheet, and then I'll get you started on worksheet 6. That'll be your homework for this weekend. Okay, so I'm looking at worksheet 6, number 2. After a light rain, water runoff to the storm sewer was found to contain 0.0100 milligrams of oil in 25 kilograms of water. What's the concentration in parts per million? So I've got 0.0100 milligrams of oil in 25 kilograms of the water, the storm water, so we'll just call that solution. It's not just water. Apples and oranges. But if I get these to be the same and then multiply by 1,000,000, I'll be fine. But I convert one or the other or both. So if I have 0.0100 milligrams, there are 1,000 milligrams in a gram. There are 1,000 grams in a kilogram. I would have kilograms over kilograms. So 0.01 divided by 1,000 divided by 1,000, and it's probably a good idea to go into scientific notation. That's going to be 1.00 times 10 to the -8th kilograms of the oil. That's tungsten you hear in the background. Tungsten! So, if I want to know my parts per million, I've got 1.00 times 10 to the -8th kilograms of oil over 25 kilograms of solution times 1,000,000. By 1 times 10 to the -8 divided by 25 times 1,000,000. Answer 0.0004 3 sig figs 00 parts per million oil. So when I post the key later, here I worked in milligrams, here I worked in kilograms, but either will give you the same ratio. Okay, that's your homework for today. Worksheet 6. You've got, there are 9 problems on there. You've got 8 more to do. If you look at number 9, they talk about parts per billion. If 1,000,000 is 10 to the 6th, a billion is 10 to the 9th. Okay? We could do trillions as well, but there's no point. Part over whole times 1,000,000. You'll find the definition on table T as well. All right, I'll post this one up. Ask me questions either via chat or via email. And if you would click turn it in when you're done, just so I know you've done it, I'd appreciate it. Have a good one.